In this video, we will discuss putting together what are called Lewis dot structures. You've learned about covalent compounds, and you know that covalent compounds are formed between two or more nonmetal atoms by them overlapping half-filled orbitals and sharing a pair of valence electrons, and this forms the covalent bond. You also know that they are able to share more than one pair at a time. Okay, if two atoms or a group of atoms are unable to achieve the electron configuration of a noble gas by sharing a single pair, they will share more than one pair if needed, up to a maximum of 3. Now, one thing that you will have to remember is something called the octet rule. Okay, the octet rule means that atoms will share pairs of electrons to have 8 valence electrons total. Okay, remember the noble gases have 8 valence electrons. So again, they're doing whatever is required to get to the lowest energy state, which is the most stable state possible. Now, there are some general rules for writing Lewis dot structures. You'll be given a chemical formula. So the first thing that you will do is you'll have to determine the central atom. The central atom will be the element with the most single dots on their Lewis dot symbol. If you need to, you might want to pull out your Lewis dot symbol worksheet and review how to determine what the dot pattern is for a given element. We're just going to be working with nonmetals, but you're going to have to remember how to draw Lewis dot symbols, because Lewis dot structures are made from connecting up Lewis dot symbols. Okay, carbon is very commonly a central atom. If there are 2 carbons in the formula, they're going to both will be central atoms. I'll show you some example of this. Okay, so that's the first thing. You have to determine which one's the central atom. Okay, rule number 2 is you're going to attach the rest of the elements to the central atom by drawing lines from single dot to single dot. Okay, and lastly, if single dots are left over, connect them to make what are called double bonds. That's 2 pairs being shared, or triple bonds. That's 3 pairs being shared. Okay, so these are the rules. Let's look at some examples. Okay, chemical formulas, if you recall from your nomenclature section, remember that they're going to have subscripts, and the subscripts will tell you for the covalent compounds the number of atoms of each nonmetal that's part of the compound. Okay, so we're going to start with O2. Now, I suggest when you try these on your own, it's not required, but it is recommended that you use colored pencils or markers, because if you assign one particular color to one element in a formula and a different color to a different element, it kind of helps you kind of keep track of and lets which valence electrons belong to which element and make sure that you're connecting them all up. It just kind of, it's a nice visual, and it also helps me when I'm grading your paper and your quizzes, that I can see very quickly what it is that, how you're actually putting them together. Okay, so look at this molecule here. Okay? There is obviously only 2 oxygens, so we really truly don't have a central atom. So they're both going to be central. Now, if you recall from your doing the Lewis dot symbols, that oxygen has 6. So I'm going to start with this oxygen over here. I'm going to draw its dots. Because remember, now, this is where the pair and single pattern becomes extremely crucial. Remember, it has 6. Remember, if you go around, you do 1, 2, 3, 4, then you do 5, 6. These pairs on the over here are called lone pairs. They are not going to be part of a covalent bond. There are some exceptions to that, but we're not going to learn about that in this particular, in general chemistry. Now, these single dots here are where the oxygen is going to want to make covalent bonds. Now, this oxygen also has 6. Now, remember I said you're going to connect single dot to single dot. So when you start drawing these, you kind of have to think ahead a little bit. Hey, you know that you're going to have to be drawing lines from this oxygen to this oxygen and pair up these dots. So it makes sense that when you draw the Lewis dot symbol for this oxygen, that you kind of turn it so that the single dots, if you will, are kind of facing each other. Okay, so I'm going to connect these two together. The line represents a covalent bond. Okay, so this is a shared pair. Okay, now there's a single dot left on this oxygen and a single dot left on this oxygen. So I need to connect them up. Okay, say 2 lines means this is a double bond. Okay, remember this is called a lone pair. Okay, it's not part of a bond. Okay, so this is oxygen. So O2 is actually the 2 oxygen atoms are double bonded together. Okay, let's do another one. Okay, this is more of a traditional one. Oxygen's kind of a little odd because it doesn't have a central atom. Okay, so we have phosphorus and bromine are in this particular one. Now, if you go and you look at your periodic table, you'll notice that phosphorus has 5 dots total and a bromine will have 7 dots total. But the patterns are such that P is going to have 3 single dots and 1 pair of dots, and bromine will have 3 pairs and 1 single dot. So since phosphorus has 3 single dots, phosphorus is going to be the central atom. So I'm going to do phosphorus with red dots. Okay, and phosphorus is our central atom. Now, again, here's these 3 single dots. The single dots are going to be where a covalent bond will form. Now, you have 3 bromines. So it makes sense that we'll draw the bromines close to the single dot so that they can get connected. So I'm going to draw a bromine here, a bromine here, and a bromine here. Okay, I'll use blue for bromine. Valence electrons. Okay? So again, I know I have 3 pairs and a single dot for bromine. So I'm going to draw the single dots on each of the bromines close to the single dots on phosphorus. Okay, this bromine here. Okay, now I have to draw the lines. Do not forget to draw the lines. Not drawing the line means the atoms aren't bonded to each other. Okay, so In this case, these are single bonds between a phosphorus and each of the bromines. This is not a triple bond. Triple bond would be lines between the same two atoms. Okay, now let's look at another group. Okay, so this one is carbons. Okay, carbon has 4 single dots. Hydrogen only has 1, so the carbon's going to be the central atom. And since there's 2 of them, they're going to share central atom duties. So we're going to put them next to each other. Now, when you're working with carbons, you're going to want to, if you have 2 of them, attach them to each other with a single bond, like that. Then you're going to have to think about what goes on. Say, don't just get that in there. Okay, don't just start attaching all the carbon dots to each other, because you have to attach hydrogens. Now, if you have 2 central atoms, like 2 carbons, it's really important that when you put the hydrogens on, that you make the molecule symmetrical. Now remember, symmetrical means that one side will look as much like the other side as possible. So that means you want to distribute these 4 hydrogen atoms kind of equally on each side. So each carbon roughly gets the same number of things bonded to it. So I'm going to put these hydrogens, so I'm going to put 2 hydrogens that's going to be attached to this carbon, and 2 hydrogens are going to be attached to this carbon. Okay, I'm going to use green for hydrogen. Each hydrogen has a single dot because it sits over the top of the alkali metal family. Okay, I'm going to draw lines to attach each of the carbons to the hydrogen. Okay, now you look here and you see that each carbon has a single dot left over. And we can't have any leftover single dots, because leftover single dots means the atoms are not obeying the octet rule. They don't have 8 valence electrons, essentially. So since they're already bonded together once, I'm going to go ahead and I'm going to hook those dots together. So the 2 carbons are double bonded together, and then each one of them is also single bonded to 2 different hydrogens. So that's all you do when it comes to these. If you go ahead and practice those, if you have questions or if you're doing them right, please come see me before you grade your paper. Good luck.